All right, hello everyone. This is the review for the expected value test that is coming up. We'll go through all of the solutions, starting with number one. Given the following test scores, create a probability distribution using the table below. Well, there are 10 numbers listed here, and we know that 30 is listed 1, 2, 3 times out of 10. So and that 30 is the smallest number. So we're going to list that first in our table. 30 occurs 3 out of 10 times, and that is 30%. The number 60 occurs 2 times, so that's 2 out of 10 or 20%. The number 80 occurs 1, 2, 3 times out of 10, that's 30%. The number 90 occurs 1 time out of 10, is 10%. And the number 100 occurs 1 time out of 10, which is also 10%. And so that completes our table. Now the next question says, what grade could someone expect to score on the test? And that's another way of asking for the expected value. So the expected value is taking the value of the outcome and multiplying it by its probability. So the outcome of 30 has a probability of 0.30. The score of 60 has a probability of 0.20. Score of 80 has a probability of 0.30. 90 has a probability of 0.10. And 100 has a probability of 0.10. So we do all the multiplication and then add all of these up, and we end up with 64. So this is the grade that someone could expect on the test score, 64. All right, moving on to number 2. It reads, you are considering purchasing insurance for some of your most precious items. Your items have the cost and the probability of being stolen as recorded below. So according to the table, a laptop costing $2,000 has a 2% probability of being stolen. An iPhone costing $400 has a 3% probability of being stolen. And likewise, a trail bike has a cost or valued at $600 has 1% chance of being stolen, and your textbooks, which cost $800, has a 4% chance of being stolen. So question A says, predict what an insurance company can expect to pay in claims on your policy. All right, so the expected value, we take the value amount times its probability. So 2,000 times 0.02 plus the 400 times 0.03 plus the 600 times 0.01 times the 800 times 0.04, and then all of that, when you multiply and add, gives you $90. So that is what the insurance company would expect to pay on this claim. Now question B says, is $100 a fair premium for this policy? Why or why not? Well, if you're the insurance company, $100 is a fair price, since it is only $10 more than the expected cost. And this allows for a small profit for the insurance company. All right, number 3, it says calculate the expected value for each free game in which a die is rolled. Which games should you play? So looking at game 1, if an odd number shows up, you win the number of dollars showing on the die. If an even number shows up, you lose the number of dollars shown on the die. So we make a probability distribution here. The outcome is if I roll a 1, then I get $1, and that's a 1 out of 6 chance. If I roll a 2, I'm going to be losing $2 because that's an even number, and that's a 1 out of 6 chance. If I roll a 3, I gain $3, all right, because it's odd. You gain if it's odd, and you lose if it's even. So if I roll a 3, I get $3, and that's a 1 out of 6 chance. If I roll a 4, I'm going to be losing $4, so that's negative, and that is a 1 out of 6 chance. If I roll a 5, because it's odd, I gain $5, and that's a 1 out of 6 chance. If I roll a 6, I lose $6, so that's negative because it's even, and that is 1 out of 6 chance. All right, expected value is simply outcome, the outcome value times its probability, so 1 times 1 out of 6, minus 2 times 1 out of 6, plus 3 times 1 out of 6, minus 4 times 1 out of 6, plus 5 times 1 out of 6, and then minus 6 times 1 out of 6. So all of that is written here, and then we just do the multiplication and add everything up, and we get negative 50 cents. So that simply means that if you play this game, you would expect to lose 50 cents. All right, here's game number 2. If a 4 or a 5 comes up, you win $2. Otherwise, you lose $1. Okay? So losing $1 would be 4 out of 6 chances, because if you roll a 1 or a 2 or a 3 or a 6, you're going to be losing. So that's 4 out of 6 chances, and that reduces to 2 out of 3. Now to win, you have to roll a 4 or a 5, so that's 2 options. 2 options out of 6, 2 out of 6, and you win $2, which is the value on the top. All right, so then doing the expected value, that would be negative 1 times 2/3 plus 2 times 1/3, and you get 0. So that means if you played game number 2, you would expect to break even. That's what the 0 means. So, question is, which game should you play? The choice would be that you should play game 2, because at least you break even when you play game 2. If you play game 1, you're going to be losing, or you expected to lose 50 cents. So I would play game 2 because it has a higher expected value.